All right. Hey, everybody. So we're looking at building a right bisector to, or a perpendicular bisector, often referred to, for the line segment AB, where A is 1, 8, and B is 5, 2. We can go ahead and do this without the diagram, but I'll just to assist us in imagine or seeing what's going on here. I've got A, which is up here. It's 1, 8. All right. Let's say that's 1. And I've got B. Sorry, I'm just going to move a few things around on my desk here. Okay. Hopefully it didn't make too much noise. B is 5, 2. That's B right there. And they make a line segment. Now, to make the perpendicular bisector, I need to first bisect this line, right, by placing a midpoint on it. And then I'm going to make an entirely new line. Oh, that was a nice straight line there. That goes through that midpoint. Let me move it with the mouse so it's in the right. There we go. An entirely new line that is perpendicular or intersects at a right angle to the line segment AB. And not only that, it's at the midpoint. Okay? This is known as a perpendicular bisector. All right? One interesting geometric characteristic that a perpendicular bisector has is that every point on it is equidistant from A and B. So for example, if I choose a point here, it's the same distance from A that it is from B. If I choose another point here, it's the same distance from A as that same point is from B, and then and so forth. So it's just a geometric characteristic that might show up in application questions. If, for example, you want to define a series of locations that are equidistant from two other locations. Whatever the case, we would like to find this line in this question. This is a perpendicular bisector to AB. Well, the first step is to find the midpoint to AB. And we would use the midpoint formula. We went over that last unit, and it looks like that. And knowing that my point A has x coordinates 1, 8, and my point B has, I said x coordinate, I meant just coordinates, 1, 8, and my point B has coordinates 5, 2. I'm going to go ahead and find the difference between the x coordinates, the sum of the x coordinates, because it's 5 plus 2 divided by 2. 5 plus 1 divided by 2, because it's the x coordinates here. All right. And then I'm also going to do the average of the y coordinates as well, which is going to be 8 and 2. So 8 plus 2 divided by 2. And as it turns out, I end up getting 3, 5. Okay, 3, 5, because 5 plus 1 is 6. 6 over 2 gives me the 3. 8 plus 2 is 10, divided by 2 gives me the 5. Now, so that's what this point right here is. It's 3, coordinate 3, and y coordinate 5, x coordinate 3, 5. The point is, and it's the midpoint on AB. Now I need to develop a line that goes through that point, right? And I mean, there's lots of lines that go through that point. I mean, I could have a line that goes through that point like that, but it's not perpendicular to AB. And so I want to make sure it's perpendicular to AB. How do I make sure it's perpendicular to AB? Well, I need to find the slope of AB. So I need to find the slope of AB, okay? Well, to find the slope of AB, this is where I do the difference in the y-coordinates over the difference in the x-coordinates. So I'm going to go 2 minus 8. 2 minus 8 over the difference in the x-coordinates, 5 minus 1. Last unit we did the slope of a line, so we're looking at a negative 6 over 5 minus 1 is 4. So I'm looking at a negative 3 halves. Is that what we're looking at? Very nice. And so this slope of the AB segment is a negative 3 halves. So the slope is a negative 3 halves. And this is the slope of AB. So I'll go ahead. This is the slope of AB. Now I need a new line that's perpendicular to it. Remember, in order to find a perpendicular slope, I actually just reciprocate it. So I do 2/3. And if it's negative, I change it to positive. Or if it's positive, I change it to negative. All right, so if the slope of this line is 3 halves, negative, then the slope of this line is 2/3, positive. And so now I basically have the ability to make the perpendicular bisector. And if I use point slope form of a line, remember that it is y minus any y coordinate on that line. Well, I happen to have a y coordinate on that line. It is 5. Remember, I'll make it pink. This pink line is the one that I'm now trying to build. I know a point on it. Its x coordinate 3, y coordinate 5, and its slope is perpendicular to AB. Okay? So I'm going to go ahead and use the 5, right, for the y coordinate. And then it's equal to the slope times x minus any x coordinate on the line. So I'll use the 3 here, right? This is the point slope, okay, form of the line. And then inside here goes the slope of it, which we discovered here, 2/3. So as it turns out, this line here is the pink line, and it's both perpendicular to AB, and it happens to cross AB at its midpoint, thus filling the description of a perpendicular bisector. Okay, so there you have it, perpendicular bisector.